Hello everyone, welcome back to KMS Educational Channel, and today we are going to learn reflection of light at curved surfaces. The first lesson of our physics book of class 10th. So let's start without wasting our time. What is reflection? This term reflection we have already learned in our lower grades from 6th, 7th, 8th and even 9th. So now let's learn the introduction of this chapter now. Introduction. Reflection means that the bouncing back of the light. Let's understand it through a diagram. If this is the normal and if the incident ray strikes the normal, it reflects back. So this is the phenomenon called reflection. Okay, do you remember the laws of reflection? Yeah, we have already learned. The laws of reflections are two. What are those? First one is incident ray, reflected ray and normal. All these lie on the same plane. This is the first law. And what's second? The angle of incidence is equal to angle of reflection. So now we are going to learn what are spherical mirrors. Okay, what is a spherical mirror? The name itself, we can tell that spherical, it means sphere type of a curved surface. So spherical mirror is a mirror whose reflecting surface is curved. Okay. Now let us find out where is the normal for this spherical mirror. As we know that plane mirror has a normal, same like that we have a normal for the spherical mirror also. So now let's see where is it. Let's do an activity 1 in our book. It's given that we are taking a small piece of foam and then we are just putting the pins to it as it is perpendicular to the surface. So now what's next? Now we are considering this foam as a spherical mirror. What happens? We can just tilt the foam, right? So we are tilting it and the diagramical representation is like this. So we are so what happens here? All the pins come at a point and they meet. So now let's know what is this point called. This point is called center of curvature. What do we call? Center of curvature. Okay. So now this is the spherical mirror. As I told you that all the normals meet at a point that is center of curvature. So now we are going to learn the components of the mirror. First one, center of curvature, that I told you. So now second one, radius of curvature. This length from center of curvature to the center of the mirror is radius of curvature. Okay, I represented it as R. So now this mirror has a middle, yes, center of the point, it is called pole. I wrote it as P. Okay, pole, third one. Now fourth one, principal axis. What is it? Principal axis, the parallel line which passes from the center of curvature and the pole is known as principal axis. Okay. Okay, so now one more term we have, that aperture. Okay, I think we hear this word in the cameras, but it's not given in our textbook, but it's given in NCERT books. So the total reflecting area is known as aperture. Okay, now let us learn the focus of the mirror. So now if the incident ray is passing and here the incident ray is parallel to the principal axis. Okay, so now it is reflecting, right? So it passes through a point. Okay, this is called focus. Whichever line it may be, from wherever it passes through parallelly, it meets at a point, focus. Okay, this is focus point. Now from the focus to the pole, this length is known as focal length. What do we call it as? Focal length. Okay, okay friends, are you understanding? This is called focal length. Okay, now let me tell you a interesting fact. This focal length can be represented easily. How? We know that radius of curvature, right? R, let me write it as R is equals to 2f. Okay, how 2f? Because focal length is half of the radius of curvature. So we can write R is equals to 2f. This equation is important. It can be used in the numericals also. So R is equals to 2f. So now let us learn SIR. What is this? standard incident rays. Okay, these are not given in our textbook particularly, but in the textbooks of NCERT, CBSE it's given. So let us learn it, and we have 3 rays, so let us learn them one by one. So what's the first ray? Okay, so let's draw it. If this is the spherical mirror, we have principal axis to it, right? So this is a principal axis, and here we have center of curvature. We know this one already, we have learned. And now, as I told you first, that whichever incident ray passes parallelly and reflects, it meets at a point called focus. Okay, this is the focus. So that is the only point, that whichever parallel line passes incident ray which is parallel to the principal axis, it passes through the focus after reflection. This is the first one. And now let's know the second one. It's just opposite to the first one. So now whichever incident ray passes through a focus, okay, then after reflection, what happens to it? It will be parallel. Okay, is it opposite? Yes. So whichever incident ray passes through the focus, then it will be parallel after the reflection. Okay, so now third one. Now let us see what's happening here. Here the incident ray is passing through the center of curvature. Now what happens? It will just go back, right? No reflection, it will just go backward. Okay, so now we are ready to make the ray diagrams. It's very interesting. Even I got very interested when I was learning it. So spherical mirrors are of 2 types, concave and convex. We know this. A concave means whose reflecting surface is curved outward. Okay, curved outward. And convex means whose reflecting surface is curved inward. Okay, so this is the difference. So firstly we are going to study concave spherical mirrors ray diagrams. First ray diagram, the position of the object. Let's see, the first one is between mirror and the focus. So this is the focus and here it's the mirror. So the middle one we have put the object. So now let's see using the SIRs. First one, whichever line is parallel to the principal axis, it just passes through the focus after reflection. Yes, so it's passing through the focus. So now what is happening? The first ray is ready. Now the second one passing through the center of curvature. Okay, but what is happening here? There is no meet up, right? Now let's see what is happening. Let's project back. Okay, let's project back these rays. So what's happening? They'll meet. Okay, so this is a point where it is meeting, right? So here the image is formed. So is this real image? No, it's virtual image. Now let's see the table. Between mirror and focus, behind the mirror. As you can see, the image is formed behind. Now here enlarge. Here object was small, image is enlarged. Now next one, it is erect. It's erect. No difference, it's erect. Then virtual image. As I told, it's virtual image. If the image would form here, then we could call it as real, but it is formed behind the mirror, so we call it as virtual image. Okay, so moving towards the next one, that is on the focus. Okay, on the focus. Now let's see what is happening here. Where is the position of image? Okay, the incident ray parallel to the principal axis passes through the focus. Okay, this is the first ray. Then now the incident ray passing through the center of curvature, it will reflect back, right? Yes. So what is happening here? Even here we find the same case as it was first. So it's not meeting, right? So let us project it backward. So as we project it backward, we are not getting the meeting point, but we tell it as infinity. The position of image would be at infinity. Okay, and infinity, this is the symbol with which we represent infinity. Okay, So now let's move to the third ray diagram. Okay. The third one is between focus and center of curvature. Okay, between F and C. This is focus, this is center of curvature. Between this I have placed an object. So now let's see. Incident ray parallel passes through focus, and incident ray through curvature it will reflect back. Yes. So now what is happening here? Oh sorry, I think I have been drew wrong. Okay, sorry, the diagram is wrong. Let me correct it. Okay, now we got the meeting point here. Here it's the image which is formed. So now let's observe the table between focus and center of curvature. Focus, center, and this is the image object. So image would form beyond the C. Okay, so how is the image? It is enlarged. The object was small, the image is big. So we call it as enlarged image. Okay. Now it is inverted. Yes, here it is inverted because real images are always inverted, not the same. Okay, they are inverted. It's real. Yes, nature is real. As we see, it is real. It is formed in front of the mirror. Okay. So moving to the next ray diagram on center of curvature. Let's see. It is center of curvature. We have placed an object on it. Okay. Yes, we can see this is the first ray. Then second ray. Okay. We got here. Okay. So this is a position of image on center of curvature itself. We got it. Yes. It is same size even. Let's observe the table here. On center of curvature. Then position of image is at C. And it is same size, and it is inverted. Yes, and it is real image. Yes. So now next, let's see next one, beyond C. It means beyond center of curvature object is placed. Incident ray parallel to principal axis passes through focus, then passing through focus will be parallel. So here it is the meeting point between focus and the center of curvature. Okay, this is the position of image. Image is formed here. Now how is the image? It is diminished. Sorry, I think so because I am drawing on the board it's not correct, but you would check your test book also. This is diminished. It means it's small. Okay, as you see it is inverted and it is real image. Yes, real image. Now let's move on to the next one. At infinity. What is infinity? I told far away object. So the incident ray coming parallelly, it would pass through focus. Then now it is coming from the focus, it would be parallel. Yes. So where is it meeting? Here. First it is meeting here. So this place we would consider as the image. Okay, it is a point. So its point, it's neither diminished nor small, same size. It is point and nothing is there. It is not inverted, and it's real image because it is formed in front of the mirror. Okay, here we have been cleared everything and we have completed the ray diagrams of concave mirror. Convex mirror, it is even simple, but it will not be passing through focus or principal. It appears to pass. Okay, that will be having the another separate video for that. Now the last topic is sign conventions and magnification. Let us learn this. This is very interesting one. What is the exact location of the image? Image is formed, yes, but where is it formed? What is the exact location? To find that, we use the sign convention. This is Cartesian plane, as we know. Here we have plus sign, this side minus. In mathematics we use this graph, right? So this is the Cartesian plane. So let us know what is given here. So here u means object. Okay, u means object, and let me write here. Okay, u means object, and if the object is placed always here, so it would be minus, right? Negative, because it is that side, na? So it is negative. Now focus is also that side of the mirror. Yes, in front of the mirror. So it would be negative. Now what is V? Let me tell you, V is image. Okay, are you understanding? V is image. If V is image, so as this is image, if it is negative, then it is real image, and if this image is positive, then it is virtual. Are you understanding? It's totally dependent on the graph. We can easily understand it, right? So now height, H means height of the object. Height, it is always positive, right? Height would be always positive, so we write it as height is positive. Okay, now these you need to understand it properly. Now moving to magnification. Okay, what is magnification? Comparing height of image and height of object. Okay, usually comparing, it sends the ratio of something, right? So it's the ratio of height of image and height of object. So magnification is equals to height of image by height of object. Okay, is it clear? So this is a formula for magnification, and it is very important in doing numericals. So now let me tell you one thing which you need to remember. Okay, let's see what is that. Magnification is equals to 1. What is happening? 1. So example, if you take same numbers 5, both are 5, 5 ones are 5 ones are, we cut and we get the 1. So here it says that height of object and image is equal. When magnification is greater than 1, what happens? Let me show you what is happening. Magnification, it means height of image and height of object is is greater than 1. So height of object goes here. It means height of image is greater than height of object. Now next one, magnification is less than 1. What happens? Magnification, directly you can write height of image by height of object is less than 1. So object goes here. So it is height of image less than height of object. Okay, so we understand this one. So when magnification is in negative, it's real. If the magnification is positive, it is virtual. And if the magnification is greater than 1, it is enlarged. As I told you, height of image is greater than height of object. If the magnification is equal to 1, it is same size as we discussed, right? So if the magnification is less than 1, then what happens? It is diminished. Okay, here we have discussed, right? So this is a case here we did, and we need to remember these things. It is very important. It may come in MCQs. Friends, one thing I missed out is mirror formula. This is a mirror formula. So 1 by f is equals to 1 by u plus 1 by v, and inshallah we'll be doing some numericals on it to understand it properly. But now let's see what is f, what is u, and what is v here. 1 by f is focal length. 1 by u is object. 1 by v, that is v is, what is v? Image. Do you remember? I have told you. So it is object distance, image distance, and focal length. Okay, 1 by f is equals to 1 by u plus 1 by v. Is it clear? Thank you very much.